of our meeting today. Like I said, we'll talk a bit about introductions and definitions of DataOps. We're going to do a bit of comparison between traditionals and how DataOps, the new framework, is going to change the game. I'm going to go a bit into the use case, and we're going to talk a bit more in depth about ETL and how is everything a bit different over there. We're going to also tell a bit about like why every data teams need this framework. How is it a necessity, not just a must-have? Is a must-have, not just like a should-have. And finally, what is the role of a data of engineers, which is up and coming and is coming very, very popular these days. Regarding the speakers today, we have Mr. Hong Pham, who is the technical lead in DataOps Consulting. Alongside with him, we have Mr. Svik Mitra, our senior software engineers, and also me as well, cloud consultants, and also your host today. I'll pass the torch to Mr. Hong Pham, and he will walk you through the first part, the introduction part of this webinar.
So yeah, thank you very much for your nice introduction, G. I will start with the simple version of the DataOps concept. So the DataOps is actually a methodology that associates with DevOps. And because of that, it will promote the automation of the data orchestration and also improve communication and integration in a data team. So how can that be possible? Then maybe let's take a look back to the DevOps methodology. Next tree. So yeah, DevOps methodology is actually focusing on the software development and deployment lifecycle. It will use a lot of automation technologies, tools to shorten the development and deployment time, and also help the developers and system operation engineers to collaborate together and working on the same goal, that is to generate detect bugs inside the application and make the quick fix, deploy fast, and make sure that the application always running. So yeah, one thing to notice here that the main role the main roles for the team here, they are just developer and operation engineer that is need to collaborate a lot inside the DevOps methodology. And so DevOps is more focusing on the application lifecycle management. So for example, we need to deploy the application. With DevOps, we can deploy the application in multiple environments automatically. So yeah, that is another thing I want to emphasize. This is for the application. We will deploy it for multiple environments. Next. And for DataOps, it's a little bit different or totally different because DataOps is more focusing on the data orchestration, which is the data pipeline here. So in normal use case, we have the data analytic use case. We have a data pipeline to ingest the data, and then we do a lot of process in between to have good data inside the data warehouse, and then the data scientist or the BI data analyst can gain the benefit from the good data inside the data warehouse. But the different things here with from the DevOps is that we focusing more on the data. So in the DevOps, we have multiple environments for the application, right? But for the DataOps, it's different. It's not the multiple environments anymore, but multiple stage. The reason is that the interested data is actually coming from only the production environment. So I mean, like when we have the application to be deployed in dev environment or test environment, the business, the insider does not care about those environments. They only truly care about what the data generated or having from the production environment. So because of that, we cannot have multiple environments like the application, with the normal DevOps concept, but we have to use another kind of pipeline here. So that's why we have here multiple stages for the data processing pipeline, not the multiple environments anymore. And in the case of DataOps here, that we will have at first we need to design the data pipeline. That is the job of the data scientist and also the data engineer, and they will also check if the data pipeline is good. If it is good enough, then they will promote to the next stage, to the validation stage, and then in the last stage, production stage, the BI or the data analyst can gain the business value from the the data model that which are already processed. So by this way, the collaboration inside the data team can be improved a lot. So yeah, and it's also a different point from the DevOps. In DevOps, the main roles are just the developer and also the system operation engineers. But inside a data team, well, I think there will be a lot of roles in here, and just small team, but a lot of roles. Yeah. So besides the data analytics use case, data ops is also can be applied into another use case, like be applied inside a machine learning ops workflow. So we can have the automation for the data preparation, and then that kind of data can be go to the machine learning training later. So yeah, the data ops can be applied in a lot of use cases for the automation of the orchestration of data.
So probably for the next part, I will take over just a little bit. We just want to have a little bit of comparison after the introductions and definitions of DataOps for people that know and may not know. So right now we come to the point that what is the difference? What is being done traditionally for data? How are they being prepared? How they transformed? How are they put into place? And what is being done differently in DataOps? So the first point probably to mention about is regarding infrastructure. This is purely mostly coming from my own experience, but data pipelines require a lot of service to functions, and it is very hard to manage if you are not somebody who knows which to point to and who to ask, and they can break very easily. Basically, if, for example, you can require a transcribe service, you can require cluster services, and therefore hosting and deployment is scary. It can get scary sometimes, and scalability is also an issue if for the local environment and the environment for you where you host the data, it's a huge difference. You are usually locally, you don't have that much computer power. So with that in mind, maybe Home, you can shed a light on how is DataOps doing things differently.
Yeah, so just to mention a little bit when about the problem that she mentioned before, when we have the data processing pipeline, it's simple that if we think it's simple, then it can be simple that the data processing pipeline will get the data somewhere and process the pipe and process the data. Is quite nothing, but that is just the surface of an iceberg. What really happens behind is really a big problem. So to have a data processing pipeline, then we need to have the data somewhere, and that relating to where do we store the data. So the data storage can be a problem, and then during the data processing pipeline, the computing resource for process the data can also be a problem, and maybe we need to scale it, and then we can have some problem with the on-premise. So based on the experience that I worked for some data ops projects in automotive and healthcare industry, I can show you a little bit what we already achieved and what we already did for the data ops things. So in the project, we are using the infrastructure as code technology. So by that way, we can scale up or scale down or manage the resources on the cloud, the infrastructure on the cloud very very well. And in this case, we are using the Terraform as the infrastructure as code technology. And the destination cloud is from the customer is the Azure. So yeah, that depends on the client to make the decision which cloud. And then we also have another component is the GitHub action. That is actually the one to run the CD pipeline for us, the continuous delivery. So by this way, when we want to have a new resources for our data processing pipeline, or maybe want to have more storage things, then we can give in the IAC script, and then we run the CD pipeline. It can be run automatically based on what we want to trigger. Then the state of the resource on the cloud will be matched to what we write in the infrastructure as code script. So by this way, we can manage it well. And there's one more benefit is that when we use, at least from my case, when I use the Terraform, it can also be a part of the documentation. So when I read the Terraform script, because it's quite human readable, so when I read it, I can see which resources are running on the Azure cloud, and by that way, I can understand more.
Great, thank you. So, but that is only solving the first problem of infrastructure. What about the second problems? Deployment locally and development of data processing scripts. So from what we observe in every projects, in every client that we have in customers, data project is popping up everywhere like mushrooms. So there's 100, maybe like even more projects running parallelly in every company. Everyone is, of course, we all know data is the new gold right now, and everyone want to grab a piece of it, and they want to be the first one to get insight out of the data. But the problem is that mostly they stop at the project level. They don't go into the production level because data pipeline, data product has a very long development cycle. And the reason for that is that the pipeline is rather fragile. So if something happened, it breaks, you have to go back again from the start. You have to make it from scratch. You have to rebuild it, move it into production, test it again. And more than that, you need to get approval. So it's a very, very fragile process. And if somebody wants to speed it up by just moving everything to locally, then they don't have the hardware for it. So basically, you need to be assigned a distinct machine, laptop or CPU with graphic cards and RAM that is adequate for the process. And that is a loss for the company already, because you don't know if you're going to produce result from it. It's basically just a loss of asset. So this is probably going to be resolved by DATAOPS, right, Hong?
Yeah. So from what I heard, and then I just remember the old days of my career. So not so old, but several years ago, when we have when I was inside a team, that's the data team. That's when we want to develop the data processing script. What we did was we download some small data from the database or some small data set from the data source to our local machine and run the data script there to test, and then we apply the data processing script to the bigger data set, and we hope that it will run correctly. So it's quite a frustrated process, but nowadays with the new DataOps concept that I'm working for the automotive and healthcare project, there are new tools and technologies to deal with that kind of problem. So the data is staying on the cloud, right? Staying there on the data storage. So we don't need to download it, because now we have some tools to run directly on the cloud, and they have the beautiful UI, and so give us the beautiful editor to edit the script for the data processing pipeline. And in my case, we are using the Azure Data Factory to do that, and the Databricks notebooks as the PySpark. As a PySpark script, or with a PySpark script to run it, so we have a flexibility to deal with the data processing script, and the Spark is also a super trending tools for the data processing now. It provides a lot of features in this direction. So by that way, when we use the data factory combining with the Databricks, we gain a lot of benefit for the data processing pipeline. And as you can see on the screen here, that is the a simple, not a simple, but a sample data pipeline that we help the customer to build with. So we ingest data, and then we run some activities with the Databricks notebooks. Behind it is the PySpark cluster, and then we also build a logging for the traceability. And in the case that if we want to test something on the local to make something a little bit faster, maybe, then we have to deploy it correctly. And in this case, the GitHub Actions will be the CI/CD pipeline to help us to deploy the data pipeline script and also the data rich notebooks to the to the products. And it's quite fast. We just need to do the to commit and push to the Git repo, and the GitHub Actions will take care of the deploying the script.
All right, thank you. Then for the last part, I think monitoring and testing. So how do you verify it? How do you monitor it for data anomalies, quality of data models, like you said, traceability, and how much RAM and CPU is being consumed? I think this is not really done differently, right? Normally for normal traditional data pipeline, you also do the same thing. You plug it into visualizations, and then you also see from that as well. So does it change a lot for DataOps for monitoring and testing?
Yes, so for the monitoring and testing, actually, nothing changed to there's not much change in this direction because it still uses the same concept. But what changed is the new tools for the automation with the DataOps. So we still need to build the log here. So for example, in this case, in every step of the pipeline, we still have to build a log. But after we build a log, we have a tool to analyze it. And in this case, we are using the Azure Monitor. So G for the next slide. Yeah, so when we build a log, we just push to the Azure Monitor, and then with this new tool on the cloud, we can do the analyze for the log and also visualization for the log, and to give more alerts based on what we want, what we define inside the data log we put in the data processing pipeline there. So yeah, in the end, the same concept for monitoring and testing, but it will be faster because of the benefits of automation.
So maybe we should move to the use case, right? One of our speakers waiting eagerly for it, and I think we should jump right into the case of ETL. So what happened in ETL, Sovik? Maybe you can step up and take the stage.
Yeah, I've been waiting eagerly for this, guys. So yeah, hi. Well, I think there has been a lot of technical terms, and you guys have to take a breather from that. So maybe we can try this. Yeah, we can walk through an use case of what is ETL or what does it do, and what was being done before, and how can our speakers, let's say, suggestions make the solutions better. So yeah. What is ETL altogether? So yeah, so ETL is, let's say, just a process where we have to gather some data from somewhere. Some of the data sources can be databases or let's say file repositories or anything. We have to gather the data from there. We have to transform it to something meaningful, which makes some sense at least. And then we have to give it or dump to somewhere where people can analyze it more. So this entire process would be called as ETL. Okay, and yeah, maybe we can discuss with the use case. Probably, yeah, 3. So the use case here, what we are thinking of is probably a dating app. Yeah, so here, oh, Tinder, yeah, why not? Okay, so let's talk about this dating app. So let's say one of our speakers here, let's say Hung, he has a complaint to make to the, yeah. Okay, so he has a complaint to make to the customer center that he has been generously, swiping right, but he hasn't got enough responses there. So he calls up the customer care and he asks, so what's going on? What can you just give me some, idea why I'm getting wrong? That's when the customer care has to do a lot of things to find out, okay, why Mr. Hung is not getting any swipes back. So yeah, maybe we can check. Yeah. So this part where you see the 3 data sources is the place from where we extract the data. So let's say when we talk about user data, then Mr. Hung has got, let's say, address, his personal data stored with, let's say, the dating app. Let's say then there is CRM data. CRM data is, for example, when not just Hung, people like Tree and me, we are also swiping a lot in the right, but we are not getting a lot of conversions. So we have also complaints. So yeah, so those details are stored in the CRM data part, and images and files. Yeah, of course, there could be a lot of places where, yeah, that's probably our home and its image. So yeah, we have a lot of storage here. So what we need to do, or what the customer care guy needs to do, is extract all this data and have to make something meaningful out of it. Like, what does Mr. Hung like? And, what does the people whom he's swiping right doesn't like, for example. So that's something. And what is common in between in Hung's complaints and, let's say, our complaints, everyone's, and example for the files as well. So what do we do with the transform data part is, after we collect all this data, or after, let's say, the customer care collects all this data, we have to do certain level of steps to make this data a little meaningful. So first, what we do is, like, let's say we locate the data where it's coming from. So that is called data discovery, something of that sort. And then we, let's say, parse the data to make it something, let's say, meaningful. Okay, so the next step, what we do is we filter it out completely. For example, we have been quite hasty about, let's say, the customer care not responding to us because of our multiple emails and blah. And yeah, now let's say these emails are redundant in a way. Like, even Hung has been sending the same email like twice or thrice or something. But we do not need so many records altogether. The customer care doesn't need. There's the same complaint he has been doing since like a week, let's say. So what we can do, what the customer care can do, is remove, let's say, all the data except for keeping one, for example. So that's this way he can filter the data, or maybe there have been some complaints which probably didn't make any sense. Like the problems probably me and Tree did. So yeah, I mean, that's when they remove those records as well and make something meaningful out of it made. After that, once this is done, let's say when the data is filtered enough, uh, the fun part comes for, let's say, the customer care guys. He has to do a little bit of programming and to find out what is business specific to that, what is more specific to, let's say, the dating app, what I need, and things like that. So he'll probably may write a logic, or find something from the data that we have to make a bit sense out of it, maybe. And yeah, then we are ending up transforming the data. And once we are done with the transformation of data, there's this most dreadful part coming out, where the QA comes in and says, is your data fine? Is this okay? So that's the part where it's the last part, which happens in the transformation part. And then finally, when all the data that we need is like makes some sense or something, we put it in, let's say, a data warehouse. So in case of, let's say, now that we, in modern sense, or when we discuss about data warehouse, we have got amazing options like, Amazon has Redshift, or GCP has BigQuery, something for Azure as well. But traditionally, we didn't have all those things. So what probably the best thing, or the best shot we could get, is probably load it into another database where some analysis could have been done. So yeah, let's say this is probably one of the use cases that we can, think about. Uh, Moving on, probably in the next slide, we can find out the cons for that. Let's say when for the approach that we kind of talked about, this has to be automated in a way. Like Hung spoke about GitHub Actions, for example, and automating jobs. But yeah, let's say we want to automate this entire thing that the customer care has to do. So in that case, what are our options, okay, for traditional approaches for ETL that we have been using? So for data sources, we don't have many options. Like, we have to stick with relational databases, or something which makes more sense than, the files, or, just JSON put in there, something of that sort. And how do we extract the data? Like the way Tree and Hung mentioned, we have to run a batch or a cron job every, let's say, a week, or let's say every day, or something of that sort. So Hung here, who has been, waiting for the response from customer care, he has to wait longer because the job has not been executed yet, or the batch process hasn't been executed yet. Yeah. And then when we talk about the data transformation part, generally it happens for the traditional approach, it happens on premises, right? So it has a big giant server, let's say. That's where all the code is, all the filtering is, everything is. And yeah, that's when it happens. Now, let's say we have to scale it up completely. There's not just 1,000 data sources or 1,000 rows that we are thinking about, but there are, let's say, multiple data sources, and the data record that we're handling is millions. So how do we do that? So scaling, in case of traditional approach, if we just have a hardware to scale, it makes our life a little tough because we have to rewrite the configuration, we have to rewrite the script, we have to rewrite, let's say, what is to be read, how to be filtered, and these steps are redundant, let's say. And again, there's an additional price of hardware that you have to pay, and of course, flexibility that makes it less for us. Yeah, even for data loading part, yeah, it completely slows down. If we have, let's say, multiple data sources or multiple places that we have to load the data in, accommodating that part in the script, it takes a huge toll on, let's say, the entire processing part, or let's say the bogged down part, and the expenses are something that is more for us. And given that we have a cloud-based approaches now, it's obviously a cheaper thing. And since the scalability or the flexibility part is something that has to be taken care of by humans like us, it's obviously a bit error prone, given what we have experienced so far. So I think we can get back to what our speakers were mentioning with the cloud approach for ETL. And yeah, the floor is yours, guys. Yeah.
Oh, sorry, I forgot to unmute myself. Yeah. So thank you, Sovik, for the use case. So, and I think as developer or software engineer, we all have the problem with the ETL sometimes. That Suvik already mentioned in the previous slide. So the first problem is always the database. So database is sometimes we use the database for the application, and then when we want to extract the data out of the database, it can give the bottleneck on the data when we do the extract, because the database is used for the application running at the same time, and we run the extraction at the same time. Then for sure the performance will be reduced a lot. But thanks to the new technology, nearly we have the read replicas for database. So in the past, when we set up a new database and set up it for the read replicas, then it is very painful because there are too many processes to go through, and we have to set up database correctly, too many processes. But with the DataOps, when we put everything into the automation pipeline, we can spring up the as many instances of read replicas as we want. And the only problem here will be the limitation in the money. So with the cloud, it's hardly for us to reach the limitation, and it's just the budget decision. And then go to the next problem is that when we have the the transformation or the loading with the slow time, then multiple cases for the transformation and loading that can be solved with the DevOps apply in here or inside the data processing, which is the DataOps in this case. So we can use the CI/CD pipeline to spawn up as many data pipelines as we want, and in these data pipelines we can give different configuration based on the script that we put there. So we can have multiple data pipeline running parallelly at the same time, and different data pipeline can run for different use case based on the configuration, and all of these things can be managed well inside the Git repository. So yeah, then we avoid all the bad situations that Sovik mentioned before for the slow way. So yeah, then I hope everyone or some of us have understood the DataOps improves and enhance the traditional way one work with data. So, however, I would like to convince you that DataOps not should have, but it is a necessity. So, and that leads us to how can we succeed in the DataOps field? Then we will need for sure the DataOps framework. Why is it? So the data team should focus only on the dealing with the data, like the data engineer or data scientist should write the data processing script and check the quality of the data, or the data analyst or BI, and so check get the business value from the data model. They should not focusing on solving the infrastructure or IT system operation issues, because in the end we still need the infrastructure or IT system to run our data processing pipeline, but that should not be dealt with the data team. And then in order to solve that, a data framework which gives us a set of tools and technology already supporting the data ops. Then by using the framework with a set of tools, the data team can start to work on the data faster. But when we use the tools in the data ops framework, then it will give us another problem. So another problem will come is that next slide. There are too many tools to choose, or there are too many alternatives to pick up. So as you know, DevOps is a mature culture now. They have a lot of tools provided on the industry, hundreds of tools to choose. Then this will be the hard decision. So this leads us to the next one. When we think how to deal with this problem, we need a new role inside a data team, which is a data ops engineer. So the data ops engineer will be the one work closely with the data team. So in two models. So the first model is that the data ops engineer can help to build and implement a framework in the cloud environment with his or her recommended set of tools and technology, and then make the knowledge transfer to the data team. Or then another way is actually collaborate closely with the data team and help the data team to build the framework based on the team favorite data tools. So yeah, that's why the data ops engineer will be the needed role in the future, closely in the future. Not in the future, but maybe now it's already a viable role.
So thank you. Thank you very much for the lights that you have shed, for the information that you have shared with us. I think that will bring us to the last part of our webinar. So probably I'll give some conclusions to our talks. But firstly, I hope that everyone have understood and achieved some knowledge over this webinar. Of course, DataOps is also a new term. It's only a few years old, about 5 or 6 years old, and it's only coming to maturity these days. And to promote this terminology, to promote this framework, is to help everyone, because as you can see, DataOps benefits everything for the data pipeline, for your data project. It helps help with your development cycle. It speed up much faster now. It also helps you to have less data defects. You can detect it easily, and in monitoring and testing, you can also find it much better with different tools. And also, you also have CI/CD from DevOps that you can reuse. And in this case, you reuse the code and you can apply it to different places. And you can modularize the code as well. In conclusion, that is more efficiency and agility. It brings your data projects into a data product, and you don't have to wait and see your data project die anymore. Now, with these implementations and with help from other people who has more experience than you, in the end, people can help build together great data pipeline and yield meaningful results out of it. And data can be the real gold we can harvest from it. And yeah, we can see the future where data can benefit everyone. That comes to the end of our webinar.